Okay, so now we're going to look at question 2, which is a trigonometric equation question. The difference between the trig equations on C3 and C2 are these reciprocal functions, cot and cosec. We've got cosec there. They're the new things really, and there's a few more identities that you have to use to try and get around solving these. So we're going to start by looking at 2a, and it says solve the equation cot x equals 2, giving all the values of x in the interval between 0 and 2 pi. Now be careful that you pay close attention to these intervals. And we're going to do this to 2 decimal places. So we're starting off with cot x equals 2. And we remember that cot x is just 1 over tan. So that equals 2. And then just by rearranging this, we get to tan x equals a half. And so x equals the inverse tan function on a half. And if you work that in your calculator, you're going to get 0.46. But remember, we're looking for all of the answers in the range between 0 and 2 pi. So it's a good idea to just draw a sketch of the tan function between 0 and 2 pi. So the tan function looks a little something like this, just sketched out. It's got these asymptotes here and here. And this value here is pi, and this would be 2 pi. So we're looking for all the solutions between 0 here and 2 pi. Okay. So one of the solutions when the angle is a half is going to be 0.46. So I'll come across here and it's got like a value of 0.46, so something like that. And the next time it's at that value is going to be pi plus 0.46, because it's going to be that much more there. Okay, so pi plus 0.46 is going to be my other solution in that range, and that's going to be 3.61. Okay, so those are my 2 solutions in that interval, 0 to 2 pi. Next question is show that this equation cosec squared equals 3 cot x plus 4 over 2 can be written like this. This is going to require one of the new identities that you get on C3. At the moment, it's taking us towards this question at the bottom, which is going to be to solve that. If you look here, we're going to be asked to solve this thing, and it's exactly the same as this thing up here. But to solve it, we couldn't solve it as it is because it's in terms of 2 different functions, cosec and cot. So the reason for this second part of the question, part B, is to get that equation all in terms of one function, in terms of cot, in terms of cotangent. So it requires an identity. So we're going to do 2b, and we're starting off with cosec squared x equals 3 cot x. Cosec squared x equals 3 cot x plus 4 over 2. So the first thing you probably want to do is just multiply by that 2 to get 2 cosec squared x equals 3 cot x plus 4. And then we're going to use one of these identities for cosec and cotangent, and these two come from dividing through the sine squared plus x squared equals 1 identity that you should be familiar with by sine squared and cosine squared, and you get 2 new identities. So the identity we're using is I'll just put this in a bracket, is cosec squared x is equal to 1 plus cot x, cot squared x, sorry. So what we're going to do is we are going to change this cosec squared x for 1 plus cot x, cot squared x, sorry. So it's going to be 2 times 1 plus cotangent squared x is equal to 3 cotangent x plus 4. And multiplying out the bracket, this is going to be 2 plus 2 cot squared x equals 3 cot x. And what this is a quadratic equation. So to solve it, I'm going to put it equal to 0. I'm going to move everything to the left-hand side. So I'm going to get 2 cot squared x minus 3 cot x minus 2 equals 0. Okay, and this is a quadratic equation. Now, you don't necessarily have to do the next step, but it just makes it look a little bit nicer, maybe. Let's say that, make a substitution, u is cot x, and then we can rewrite this top equation as u squared, 2u squared minus 3u minus 2 equals 0. Okay. And then we want to solve this quadratic equation, so we're going to try and factorise it. And you look at it for a little bit, and it should factorise to 2u plus 1 and u minus 2 equals 0. Now, you don't necessarily have to do this step here. For some reason, it just looks a bit nicer and makes it a little bit easier to maybe factorise, I don't know. So anyway, the two solutions we have then are u equals minus a half and u equals 2. But remember, u is something we came up with, so let's just write that back in terms of cot x, because u is cot x. So cot x equals minus a half, and cot x equals 2. Okay, so we've got to remember, right back to the very first question, that cotangent x is actually 1 over tan. So 1 over tan x equals minus a half, and 1 over tan x equals 2. So tan x equals minus 2, and tan x equals a half. I'm going to rearrange those. And we've already solved when tan x equals a half. We've got 0.46 and 3.61. So those are the two solutions for this that come from there. So we've got x equals 0.46 and 3.61. Notice the question is nice because it sort of talks you through it. You've already done bits of it. You've already put it in this form so that you can solve this equation. And when you come to solve this equation, you've already got some solutions to the first part of it anyway. So we just need the extra solutions that come from this one, this tan x equals minus 2. Well, that's not a problem because we've already done it essentially, done the similar problem. So x equals tan to the minus 1 of minus 2. And using the same argument, just whack it in your calculator, and then get one value, and then look at the curve to find the other value. You should get 2 more values of x, 2.03 and 5.18. That's a 5. Okay, so those are your solutions to the final part of the question.